So it's 11 a.m. So let's start. Good morning, everyone. This is Tafsir Fatima, optometrist. Welcomes Dr. Cathy Stun, ma'am, who is going to take live webinar on the topic of circadian rhythm and retinal disease. So, ma'am, are you here, ma'am? Hello? My voice is audible or not?
Yes, yes, you are audible.
Okay. Okay. Ma'am, can you hear my voice, ma'am?
Yes, your voice is audible.
Can you hear me now?
Yes, ma'am. Yes, ma'am.
Oh, yep. Let
So
me
you
stop.
can start, ma'am, with this topic.
Okay, can you see the full screen? Because it's not letting me go into slideshare mode. I mean, to slideshow mode.
Yes, we are watching this, ma'am. Is it
Is it big enough?
visible? It is visible, ma'am. Your screen is visible right now.
Right, but is it big enough? Is it big enough to see it all?
Yes, ma'am. You can go ahead with this.
Okay, I just hate when it won't go off the main screen. Okay, so again, we're having the same problem that the other person was having. We're having the same problem getting the slides to change. The arrows aren't showing up here. Let's see if I can do it a different way. If not, you guys have it. You can put it up and I'll let you change it.
Adnan, are you here, Adnan?
Yeah, I'm here. But
Adnan, ma'am. Adnan
oh,
is
I'm not.
Adnan. Are you here?
Yeah, he said.
Yeah, I'm
There.
sure.
So you can help with the. Can you help, ma'am, with this?
Let's see if I unpin it. Will it let me? Nope. That's not what you want to do. Okay, it's there. It's just not letting me.
Okay, ma'am, I will share my screen.
All right, let me get off mine then.
Is it visible to all?
It looks
Yes.
visible to me, but I just need to move you off the screen. There's a, yeah, you need to move that box off the screen. Thanks. So I can see my slides. Okay, should that X be in the middle of the screen there or not? Okay. All right, so you can hear me okay, everybody?
Yes, ma'am. Yes, ma'am. You can start,
Right.
ma'am.
So I wanted to talk about circadian rhythm uh, and retinal health, but a retinal disease, but it's really talking about circadian rhythm and how it affects many of the things that we do in our practices. So if you could just advance the slides, I have no disclosures. And we just want to start talking first about light and health, and knowing that one of the issues that has really come up is that in our current environment, we have light all the time. And because of that, in some ways, it's at the expense of our circadian system, which is the light dark or sleep wake cycle. And so we can go to the next slide. And any kind of biological rhythm is some kind of a cycle. And in some cases, it's influenced by internal factors and external factors. But any biological rhythm that has a period of about 24 hours, they call that a circadian rhythm. And believe it or not, we have these circadian oscillators in all the cells of our body. Next. So when we say circadian rhythm, it's generated by what we call an internal clock. And that clock goes on no matter what's happening outside of our bodies. And the internal clock that regulates circadian rhythm is really synchronized, or what they call entrained, to the light dark cycle by some kind of a time giver. And in our case, the principal time giver is light. And so we can actually, even by using light, not only have the normal light dark cycle, but we can reset that cycle. We can phase advance it or phase delay it, which is something that people are starting to do before they travel to another time zone. Next. So this is just a graphic of that. And again, light is this strong time giver for the circadian rhythm. And we know that light gets into the brain through the intrinsically photosensitive retinal ganglion cells. And we know that darkness cues the release of melatonin, which is what helps with sleep. And so the pacemaker itself is located in the suprachiasmatic nucleus, which is part of the hypothalamus. And that's where the light coming in is terminated. So it's called the retino-hypothalamic tract. And the light goes to hypothalamus. And from there, from the suprachiasmatic nucleus, it actually goes to through the pineal gland and ultimately pituitary gland as well. So let's go to the next slide. And so in the daytime, the light signals the system in a way to keep us alert. And at nighttime, we produce melatonin for falling asleep and staying asleep. And the key is that when light comes on in the morning, it suppresses the melatonin. So this circadian rhythm, just so you appreciate it, is not just about sleep-wake, but it has an effect on all our body systems. It regulates blood sugar and cholesterol. It has an effect on mental health, so that if it's out of sync, people can be depressed, or it plays a role in bipolar disorder. We now know that it has some role in dementia and other neurodegenerative diseases, and I'll talk about all this a little bit more. It is involved in DNA repair, which prevents some cancers, and it even influences the effectiveness of anti-cancer drugs. Next. So we do have a retinal circadian clock. It's autonomous. It controls photoreceptor renewal. It regulates dopamine and melatonin in the retina, and it has independent oscillations. So in the retina, we know that there are cells that are generally not for seeing, and those are the intrinsically photosensitive retinal ganglion cells, or IPRGCs. They actually have a photopigment called melanopsin, and melanopsin has the property of measuring ambient illumination. It actually contributes to visual discrimination and drives a variety of physiological responses, like the synchronizing of our circadian clock to the light dark. It plays a role in regulation of pupil size, modulation of sleep, and the suppression of pineal melatonin production. So the pathway is that you go from the retina through the retino-hypothalamic tract to the suprachiasmatic nucleus, which is in the hypothalamus. And from there, you have pathways that go to the superior cervical ganglion, ultimately to the pineal gland. And the melatonin is produced in the pineal gland. And then we know that this retino-hypothalamic tract is this photic neural pathway. It starts in the IPRGCs, where we have melanopsin. Then the axons of the IPRGCs project to the suprachiasmatic nucleus, and the suprachiasmatic nucleus interprets that information on light and dark and day length and helps to entrain our body clock, and it directs the pineal gland to secrete melatonin. So the highest density of receptors are in the suprachiasmatic nucleus, but there are receptors in anterior pituitary and retina. And you can see from the slide that melatonin enhances what's called GABA A receptor function and may even be responsible for sleep-inducing effects. And they're expressed in many different tissues, but they really don't know yet what's the significance of that in some of those areas. Next. So just so you know, the reason that it's so important to sleep, in part, is because melatonin is a very powerful antioxidant. It scavenges for free radicals. It stimulates the synthesis generating enzymes, and it protects our DNA from oxidative damage. And melatonin that's circulating helps to synchronize our circadian rhythm and promotes, obviously, our sleep onset. And melatonin production is inhibited by even low levels of light. So one of the things that I tell people, and you should talk with your patients about, is if they need a night light, for example, if they get up during the night, that light should be more of an amber color. It should be a light that has minimal blue in it, because white light, even for short exposures, can really affect the circadian cycle. The other thing is, when we talk about Alzheimer's disease, we know that melatonin decreases during aging, and you certainly will hear that as people get older, they have more sleep issues. But they have found that in patients with Alzheimer's disease, they have a more profound reduction in melatonin. And they have found two things. One, with melatonin supplementation, they sleep better. They have less what's called sundowning, which is where people who have Alzheimer's disease often get more agitated later in the day. And it slows the progression of cognitive impairment. The other thing that's been found is there have been some studies using light during the day to better regulate the system of people who often are in a nursing home or some kind of a situation where they're not getting outside very much. And so there are some studies where they've taken the tables that people sit at during the day and actually put light boxes into the tables, with the appropriate lighting for the day, and there has been much less sundowning in those patients. Now, if that circadian rhythm gets disrupted, you can go back one, there are a number of diseases that are associated with that. So one of the things that we have to be aware of is that if light is not getting into the eyes properly, if it's not being transmitted by the IPRGCs, if we're not getting good sleep, if we're getting too much blue light late in the day, these are some of the diseases that patients can have, not all of which you'll be knowing about necessarily. One is called seasonal affective disorder, which you may see less there. I don't know. We tend to see it here, and I'll go over it in a few minutes. Jet lag is another one. Shift workers who have to work often at night, and anything that leads to sleep disruption. So if you go to the next slide, seasonal affective disorder, it's a type of depression. It tends to happen, at least here in the US, to people more during fall or winter when the daylight hours are shorter. And they feel that less daylight may set off some type of chemical change in the brain. But primarily what people notice is as the days get shorter or the daylight hours get shorter, they're often depressed. They may have low energy. They find themselves craving carbohydrates. And in some cases, they actually withdraw socially. They tend to sleep a lot more, and they lose interest in daily activities. And it's a pretty significant issue where I live, where in the wintertime, it's cold, it's not always sunny, and it gets dark probably at 4:30 in the afternoon. We actually change our clocks twice a year. So once the winter sets in, it's dark early. It's starting now at this time of year to get dark a little bit later, but it's still not that late. And so it's more of an issue. But what we do know is that what they call high lux blue enriched light at a level of 750 lux, which isn't terribly bright, can be very helpful if it's used during the daytime hours, especially for most people in the morning. And it will help to produce the hormones that we've been talking about. And so it helps to prevent or lessen seasonal affective disorder. The thing that most people have heard about for it is standard white light at 10,000 lux. And the one thing you have to be careful about, whether you're getting a device that has white light or blue light, is that when it says something like 10,000 lux, you have to ask at what distance from the person, because some of the boxes have to be almost up against your face to get 10,000 lux, and others can be a short distance away. And so even if it says the device has 10,000 lux, it doesn't mean it's going to have it where you place it, depending on the device. But they did find that blue light could work as well as white light at a much lower intensity. And in fact, many years ago, I had a small box that had white light, and then the same company produced one with blue light. And so it's been known for some time. Now, if you don't want to have jet lag, you can either advance or delay your circadian cycle by using light to entrain your system to be closer to wherever you're traveling. And there are several companies that have produced even eyewear that you can wear with a green light, and it you put in where you live and you put in where you're going, and it will even tell you a number of days ahead how to wear these devices so that you're retraining your system before you travel. And we do know that shift workers, especially people that work, for example, at night, there's a fundamental misalignment then with the normal circadian rhythm, and that tends to increase the risk of workplace accidents and injuries, because many of those people don't sleep all that well during the day either. Now, any kind of sleep disruption, so there's one called delayed sleep phase disorder, and about 16% of teens tend to have it. They tend to go to bed late, they have difficulty getting up early, and they do find that, again, if they have the white light for a couple of hours early in the morning and restrict light, especially light that has a lot of blue in it, after 4 p.m., they do better. We do know that anyone who's blind, because they are not getting that light into the brain, have something that used to be called free running circadian rhythm. They now call it non-24 sleep-wake disorder. And they often find that their sleep is disrupted because they're not getting the signal to the normal sleep-wake cycle. There is a company, at least one here, that has produced a medication that can help these patients. And any kind of irregular sleep-wake rhythm, if there's no consistent pattern to sleep, or you find yourself sleeping for short periods, some of those things you may be doing on your own. Some of those are connected to things like dementia and brain injury. And if there's chronic sleep disruption, you can get, or at least there's a connection to Alzheimer's disease, to Parkinson's disease, to cardiovascular disease, to any type of metabolic syndrome like diabetes and obesity. And like we mentioned earlier, also to psychiatric disorders like bipolar disorder and depression. So what is it that we need to counsel our patients? What should we be doing ourselves? We need at least 500 lux at the eye for a minimum of 2 hours in the morning. Now, where you are, maybe it's warmer most of the time, but we're about to have about 1 meter of snow here. So I have to tell you that I don't just go outside and sit in the bright light. First of all, it's often not very sunny. And so if you can't get it outdoors, you can get it from light boxes. You can get it by sitting near a window if it's somewhat sunny outdoors. And while whiter light with more blue is preferable, so there's something called Kelvin. Light is measured in as a color temperature. 5,000 Kelvin is much brighter white light, very similar to the sun. Whereas if I said 2,500 Kelvin, I'd be talking about the sort of yellow light that comes from an incandescent bulb. And so the total amount of light is a little more important than the color, but the closer you can be toward natural sunlight, that also is helpful. And they do say that while more light helps to a point, if you're past about 2,000 lux, there's not really an advantage to going brighter. But the goal here really is melatonin suppression, so you can stay awake all day. And blue light is like a switch. It turns off signals from the IPRGCs. There's no damage to ganglion cells or any retinal structure from blue light. You do hear a lot today about the dangers of blue light. I think it's a bit overblown. I think that if you're in front of a monitor, unless you're up close and in front of it 24/7, you have to remember that the amount of light coming off our devices, while it's of some concern, is about 100,000 times less than what we get when we go outside in the sun. So I think that the issue may be if we're exposing ourselves to it late in the day, and some of that is the blue light, some of that is just that we're keeping our brains active at a time when we should be slowing ourselves down. But I really am not of the camp that we have to worry about the blue light from our devices in terms of retinal damage. And we'll talk about a little more about that in a few minutes. But again, you need to suppress melatonin in the morning so that you'll stay awake. But we do know that heavy light at night, there have been some studies done in places where there's a lot of outdoor lighting, and it shines in the windows of people's homes. And they found that people that live near that, there's a higher incidence of both breast cancer and prostate cancer. So there is some concern for too much light at night. I tell people they need to be sleeping in a room that's dark. And in fact, where I sleep, There's been some more building of some homes, and some trees and things that were there have come down. They're not that close to my home, but enough that I notice more light coming in at night from probably street lights on some of the streets near me. And as a result, I'm thinking about getting some darkening shades to make the room darker. So what happens? This is kind of the sequence that we've been talking about. So the retinal ganglion cells get light, and that suppresses the melatonin. But at night, in the dark, the melatonin gets released, and that's obviously leading to our sleep. And then we know that a narrow band of blue light suppresses the release of melatonin. That's why we can say, and we'll talk about what the word blue blocker means, but why that may be helpful in some cases. And we know that the blue wavelength suppresses melatonin, so we need to be a bit careful on our devices. And if melatonin is really suppressed to a sufficient degree, then some of the beneficial effects won't occur. So we need that melatonin. It's a powerful antioxidant. Our system every night, when we sleep enough and sleep properly, really goes through a whole cleansing that's very, very important. Now, melatonin is not the principal controller of sleep, because if it was, every time it got dark, we'd fall asleep. But we do postpone it when we turn on lights or television or we're on our devices. But beyond melatonin, just know that the whole system relies also on the hypothalamus because of the suprachiasmatic nucleus, something called the ventrolateral preoptic nucleus, which is an area that initiates sleep. And there's something called sleep-wake homeostasis, or some people call it sleep pressure. The longer you are awake, the more your brain builds up a type of pressure to sleep. So that's just to let you know that melatonin isn't the only player in all of this. So the next slide. So what does blue blocking mean? Well, there are lenses that you probably even prescribe now that are called blue blockers, but they are clear. And there are other blue blocking lenses that have a much more sort of orange or amber color. In this particular case, they were looking at the effect of an LED screen with a dominant wavelength near to the peak for melatonin production. And they had some of them wear clear lenses and other blue blockers, and they monitored their melatonin. And then they looked at how sleepy they were every 30 minutes. You can go to the next slide. And the key here is this. If you're talking about blue blocking lenses, you need to have lenses that are more of that orange or amber color. And so because they said that in this study, the attenuation was 98.3%, then it seems to me, although it didn't say, that it was likely these orange tinted blue blocker lenses. They weren't the clear blue filtering lenses that many people are being prescribed today. And at 482, you're near the peak sensitivity for melatonin suppression. Most of the clear blue light glasses really only provide a low to moderate blue light filtration, probably about 30%, because they tend to not be close to the peak for either the melatonin regulation or even the true blue light hazard. So we can go on to the next slide. And so in that graph, the transmission dropped to 80% at 410 nanometers, except that that's really far away from those two peaks. So we can go back to the explanation. And so at the peak of melatonin sensitivity, the other way, with the slides, yep, the transmittance is like 90%. So really, the melatonin reduction turns out, when you do the math, to be only about 3%. So the question is, should we even be suggesting these lenses to people? And I'm talking about it only from the standpoint of our circadian system. There are some people who do feel that when they wear those lenses, even though the amount of blue blocking is minimal, that they are more comfortable at the computer. And that's a different piece than what we're talking about. But we do know that blue light can suppress melatonin, and we know about the effect then on sleep. The cancer connection is a little more speculative, but the big thing I want to say is the suppression of blue light by these lens coatings, these clear lenses, I think is somewhat of questionable value. Maybe from a comfort standpoint, they may help. But one, I don't think they're blocking much blue to the retina. And the other is they scare people by saying that they're going to have retinal damage if they don't wear the blue blocking. And that's, in my view, not true, because, again, it's 100,000 times brighter when you go out in the sun. But what are some of the benefits of blue light? Blue light during the day can be beneficial and even necessary. So we don't want to take it all away, which is a good thing that those lenses don't block it that much. So the next slide. So some of the hormones triggered by blue light include cortisol and serotonin. In the case of cortisol, the sunlight exposure first thing in the morning that we talked about stimulates the production of cortisol, and it signals our body to wake up. And serotonin is critical in the morning because it later leads to production of melatonin. And so we won't be able to produce as much melatonin later for optimal sleep if we don't get the serotonin in the morning. So again, if you can't go outside, sit facing a sunny window. Most measures of lighting, when places are designed, take into account the surfaces around us and how light is bouncing off those surfaces. But most lighting designers do not account properly for the light we need at or getting into our eyes, or the way that light might be modified during the day, even in an office setting, so that it is guiding our systems more appropriately from wakefulness towards sleep. I actually took a course on lighting and health, and one of the projects that we did was we were given various office setups in different countries and with different parameters, and asked how we would design the internal lighting so that it was both useful in terms of what we need to see, but also respecting the circadian cycle at the same time. It was very interesting. How do we maintain a healthy rhythm? Again, 2 hours of sunlight in the morning. Exercise helps. Avoid caffeine after noontime. Limit light before bed. Have a consistent sleep schedule and make sure the room is dark. We can use these more amber colored lights at bedside, or if you need a night light. And remember to get blue in the morning. The red light really has no effect on a circadian clock, which is why we can use red light later in the day. But when I see that and show that to you, and you can go back one, what I want you to really appreciate is that this is not just something that we should be telling all our patients. We should also be thinking about patients who come in with issues. So, for example, when I have brain injury patients coming in, what I tell them is that you need sunlight in the morning, you need to get some exercise. They should be really careful with caffeine. For the most part, I tell them probably in the beginning to eliminate it entirely if they can. They want to limit time on any kind of devices. Now, many of them are bothered by devices, so they're already not doing that as much. But any kind of light, if they're watching television, anything like that, they need to limit it before bedtime, even overhead lighting. And I do tell them they need to go to sleep and wake up at the same time every day, and the room should be dark, not only blocking any windows, but even if you have a door to a room and there's lighting in the hallway and it's coming underneath the door a little bit, you should take a towel and roll it up and put it up against the door so that the room stays dark. And you want to make sure that you get that much bluer light in the morning, but that you do not put yourself in a situation where you're going to get that blue light at night. And so I want to show you this slide because one of the things we need to think about is we do need good lighting to be able to do the things that we do. Obviously, we can't see our materials in the dark. We can't cook in the dark. You know, we can't get dressed, at least to check how we look, in the dark. And so what we want to do is find a way to have the right lighting for performance, but also to change lighting as we go through the day, or to at least change our habits and our environment in a way that we also are promoting not only good sleep, but better health. Because the effect of light on our system is tremendous. So I put this as questions, but I'm going to open it up to questions from all of you as well. But one is blue light helpful or harmful? And we know that it is a negative in terms of our sleep wake cycle if we get too much of it later in the day. But I don't like the word harmful in the sense that there have been companies over the last number of years who really have been pushing these blue blocking lenses, which we now understand are really not blocking that much of the blue, but they make people feel uncomfortable in the sense of saying, you know, you're going to end up with eye disease if you don't wear these blue blocking lenses. And I really think that's not the case. I think that argument is a little bit pushed in a way that is not completely true. And that if we want someone to wear those lenses because they are helping them to be more comfortable at the computer, that may be one thing, but I know that they're even having young children wear them a lot, and I'm concerned, even if they're only blocking some of the blue, are we going to see any negative effects down the road because they've been wearing them too much and too long? I don't know the answer to that, but I would suggest that they're not as necessary as some companies are making us believe. We know that it is helpful in the morning. We know that we want that blue light in the morning. We know that it should be avoided later in the day. We know that we need to suppress melatonin in the morning, because if we suppress melatonin, we're going to be alert and awake. But we need to allow for good lighting to get the serotonin that we need, because that is going to allow for more melatonin production later in the day. We know that we need that melatonin not only so we will sleep, but because it's such a powerful antioxidant. And we know that when people are exposed to too much light, and especially blue light later in the day, it may have detrimental effects on many aspects of our health, not just sleeping, but when we don't sleep, we're not getting the full effect of the melatonin as an antioxidant. And we know that there can be effects on our physical health, like diabetes and obesity. We know that it can have a mood effect. We know that it may be promoting, on some level, additional breast and prostate cancers. And we know that when we sleep more and we allow for good melatonin suppression in the morning, then we are much more alert and have a much better opportunity to get through our day with less errors and less mistakes, and remembering more of the things that we've been working on during the day. Now, should we recommend blue blocking lenses? Again, the ones in the eyeglasses do not block that much of the blue, and so I don't think they are completely harmful, but I'm not sure, other than if some people do notice better comfort if they're on a computer a lot of hours during the day, I'm not sure that we need to be promoting them as much as many companies are. There also are blue blocking intraocular lens implants. I don't deal with them as much, but I can tell you that some of them have a kind of a yellow color to them, and some people find they're bothered by that. But I do have a concern that if they're worried about the effect on the retina of not having some kind of blue blocking in the intraocular lens, I don't think that's so important. I do think you may need more UV protection because we are getting less ultraviolet to the retina as we age because of the buildup of lipofuscin in the lens, in the natural lens. So that may be needed, but I'm not sure the blue blocking is something that you'd want to recommend to patients. And in terms of lighting, I'd recommend to anyone today, if they are purchasing, for example, a lamp for their home, they may want something that can be changed over the course of the day. And by that, I mean there are bulbs now, and at least here in the US, they've gotten much, much less expensive. They are LED, and I know there are concerns about LED lighting, but these LED lights can be changed from being bright white, or that 5,000 Kelvin we were talking about, all the way down to 2,700 or 2,500 Kelvin, which would be that sort of yellow light that comes from now if you had an incandescent bulb. And so what you can do is you can have a lamp that you have brighter earlier in the day if you need it, and you can set it to have less blue later in the day when you're working. And so that way you're getting the best of all worlds. You have enough light to work by, but you're changing the color temperature as you need to during the day. So I'm going to stop talking now and give everyone a chance to ask some questions. I don't know if I'm able to see the chat. Let me see. I can see at least some of it, but I don't see anything written there right now. The other thing on the last slide here is, I think it was around 2015, there was something called the International Year of Light. And since then, if you go back one slide, they no longer have the Year of Light, I think up one. But now they have, you can go up one slide, I think, the one you just had about the Year of Light. But anyway, in May, they now have every May what they call the International Day of Light. And I know that they don't talk about it much here in the US, but I certainly have seen on the website for it that around the world, and so maybe it's happened more for you, that there are many different programs at universities and in communities and things to often learn more about light and various aspects of light, and just to respect the fact that we need to let the sunshine in. And so I think I just saw a question pop up. Someone asked, in terms of color blindness, are there any effects to the circadian system? Now, color color blindness or color deficiency has to do with the cones in the retina. And we're talking about the IPRGCs, the intrinsically photosensitive retinal ganglion cells. So there's no connection there. You would still use the same kind of lighting and the same color of lighting. It has no connection to color deficiency in the sense that that's the cones, and we're talking about the IPRGCs.
Can I ask one question, ma'am?
Sure.
Before that, I'll admit that yesterday night, my sleep went for a toss. Okay. Most of the time, when I get an interesting case, I keep thinking about it, and that's what it happened yesterday night. Okay. Ma'am, my observation that most of the modern stores they use so many LED lights.
Yes.
Though some of them are really bright. I did visit one of the store where they do repair mobiles. Okay, so that's a small area, and the light was so much. So I asked him how you are managing with this. He says, "Sir, we lost our hair. We are losing our hair because of this so much intense light."
Well, there's a couple of things. One is, a lot of lighting in shops used to be fluorescent lighting, and fluorescent lighting had a lot of blue, and so
Right.
it was not the most comfortable lighting. In my office, I had something. I had a type of fluorescent lighting that mimicked the sun, and so I could work under that much more comfortably, but I certainly would not have wanted to light my office with typical fluorescent lighting. So the fact that I was able to find lighting that mimics more like the sunlight, that was very helpful. We do know that many people, well, I should say this, many people think that if you're having difficulty seeing, more light is better. And that's not true. Because if you put too much light, then you start getting glare and discomfort. Some people get headaches. So that sometimes you need a couple of things. One, overhead lighting only provides so much. Never mind, we're not even talking here about light getting into the eyes. But the overhead lighting doesn't need to be that bright, in the sense that if you're doing a task and you really need extra lighting for that task, you should have some type of an adjustable lamp, like a gooseneck lamp, with an arm on it that's adjustable, so that you can direct that lighting right onto what you're looking at. It's like when we have patients who are sight impaired and they read, because they often have to hold their reading material very close, we have them get a lamp that can go right in between the light that can project right in between the book and their body, because they're blocking some of the overhead lighting when they're doing that. And I think that in some offices, what they've done is they put these baffles over the lighting so it can be directed a little bit better. But I tell people, if there's an opportunity to reduce it, either turn off every other light or put it where you really need it. When I designed the last office I had, I made sure that the lighting fixtures, they were fluorescents, but one, we used these full spectrum fluorescents, which were like the sun. And then we made sure that the full light was not over where our computers were, that it was over a table where we were doing more reading with patients, but that it was all our computers were placed in a way where the lighting was slightly less in the room, because that was more appropriate to have the room light be less, because you want the screen then to be brighter. So you're right. If the lighting is too bright in a place like that, they either need to put something up that kind of dulls the light, or maybe if they can control some of the bulbs, maybe if there's several fixtures on the wall and they're all controlled from one switch, maybe they can take the bulbs out of one of the lights or two of the lights, to be able to have enough lighting but less. Yeah, because that can't be comfortable. Too much light can be almost as bad as not enough light.
The first thing I do when I go home from my practice is, moment I reach my room, I just make it dim, because I am exposed. We are in a showroom. We are exposed ourselves to so much light,
Right.
and
I have
it
been to your
definitely.
practice, so I know. Yes. Um, I have been there,
Yeah,
Sanjay. But
yeah.
but
So,
also the other thing is, and I do this when I go out, especially in the summer. Sometimes I don't know how bright it's going to be here. I carry a baseball cap with me, and so
right,
if I
ma'am.
go in somewhere that's too bright, or all of a sudden I come outside and it's brighter than I anticipated, I just put that cap on, because just blocking that
Yeah,
light coming from above is helpful.
yeah.
Even if you're wearing sunglasses, light is still often coming in kind of through the top and the side a little bit. And so I find that I wear sunglasses that are not necessarily all that dark, because I prefer to then just have some kind of a cap to block the light
Mm,
from above. But
right,
there are a
ma'am.
few other questions here. So thanks for asking that,
Yes,
Sanjay.
ma'am. Yeah, ma'am.
Um, it says, what about disco lights in clubs or musical shows? How dangerous are they to our system? Well, I wouldn't say that they're inherently dangerous. I think that if they flicker at a certain rate, that becomes a problem for some people, not everyone. I think that we don't want to expose ourselves to some of that kind of thing all the time. But again, for the most part, if you can tolerate it or not. So if you go in a place, just like Sanjay was just mentioning, he went into a store and the lighting was really bright and bothersome. If you go into a musical show and that lighting is constantly changing and your body has to constantly adjust to that, what the discomfort comes from a lot of times is your pupil constantly opening and closing. And I do think that if you find that it is bothersome to you, then you need to do what you can to avoid it or lessen it. Someone else is asking if any person is having retinal disease, which cause changes or damage in ganglion cells. In that case, can the circadian rhythm changes happen? Again, there may be some issues, but again, some of the retinal issues are more to the photoreceptors. Are we talking about the intrinsically photosensitive retinal ganglion cells? They're about 2% of all the photoreceptors. So I don't know, depending on the disease, exactly how many would be affected. I think you're more likely to have issues when the lens or the cornea are more clouded or changed. But certainly if someone has significant retinal disease and there is enough damage to the ganglion cells, then it will probably affect those IPRGCs as well. And someone is thanking me for the presentation. Thank you. But the doubt here is, I get that blue block lenses only block a small fraction of the total daylight. Well, the total blue light. But since mobile screens, wait, I just lost it here. But since mobile screens have a highly concentrated LED spike right at the 450 nanometer blue light range, doesn't the lens effectively target and reduce that specific artificial spike? Wouldn't that still be relevant for circadian rhythm at night? So if the lens of the eye is blocking some of the blue, that's one thing. I think you're asking if the lens would target that specific peak. And what we do know is that the blue blocking lenses, and I do not have graphs for all of them because most of the companies don't release that information. The one that I had for Zeiss, someone got that for me, but I imagine that most of them are similar. I have not tested all of them, but if the peak that they're blocking is not near the peak of either the melatonin production or the blue light concern, then it may or may not have the effect that you want. And so again, you're only blocking a small percentage. If blue light is truly an issue for our sleep, then we need to be blocking more of it. And that would mean with a lens that's more of an amber color, that definitely, now it may not be every amber lens, but generally lenses that tend to be an amber color, if you look at the transmission, they don't let that much blue come through, but you have to know the lens. There are companies that actually make particular amber lenses that block the blue, and if you know that, that's what you would want. And so, yes, some people may be more sensitive and should probably wear some type of amber lens later in the afternoon and early evening to promote better melatonin production. Also, we do know that if you can't change the color of the lighting, that just reducing the lighting, like Sanjay said, where he makes the room more dim, that can have a pretty good effect as well. And so, yes, you want to give people that kind of advice so that they have a better chance of having their system work appropriately. Someone else is saying, students today are scrolling up before sleeping, many times including me. But are they unintentionally disorganized and their cycle results in lack of energy early in the morning? And what does everyone need to understand about that? So the first thing is, yes, I'm as bad as the next person. I happen to charge my phone usually near where I sleep. I tend to pick it up and scroll and read a few things, before I'm going to sleep. And that's probably not what I should be doing on a lot of levels, not just because of the blue light, but also because of just not promoting the kinds of way you should be slowing your system down and preparing yourself for sleep. There are filters that can be gotten for the phone, not only the dark mode on the phone, but there are filters that can filter more of the blue light if there's a concern. But I think all of us have to learn to put our devices down and get better sleep. And then it says, what if you are totally blind? Are they feeling dizzy or lazy due to not receiving the impulse to their brain? We do know that patients who are totally blind, if they are not getting the light as the signal to their sleep-wake cycle, they often can have what's called free-running circadian rhythm, or it's now called non-24, and their sleep-wake cycle can be quite disrupted. But because you can't use light to treat it, because they can't get the light in an appropriate way, there is a medication. There are a couple of medications, I think, out there. One for sure that has been developed in order to help their system retain a proper rhythm. And so Sanjay is saying the LCD panel TV in my home does not strain the eyes. Well, the panel may not strain your eyes. What's coming off it in terms of lighting? First of all, we're not sitting that close to it unless it's a computer screen that you're sitting very near. And Sumit from LV Prasad saying, I have a question. How does glaucoma affect circadian rhythm? There is some, I don't know it off the top of my head, but there is some research on that. And I do know that there are some concerns about how glaucoma is having an effect just generally on the brain. but I would have to look that up more in terms of specifically the circadian rhythm. But there's no question that we are learning that glaucoma has many effects that we never really thought about or understood before. And I'm sure that that is one area where there may be an effect. And also, a lot of patients who have developed glaucoma, many of them are also patients who are older. And as we get older, there is more blue light filtered from our natural lens. But we do know that specifically for glaucoma, that there are a number of brain effects. And so the effect on the sleep-wake cycle, and also the fact that as patients are older, they're producing less melatonin is an issue for sure. So it's complicated, but certainly something to think about, or even to ask patients. I don't think in our histories, most of us even ask what do you have any sleep issues? What's the quality of your sleep? How do you sleep? What are you doing right before you go to sleep? And maybe for some patients, that may be important for them to overall have better health. Because many of the patients we see, one of the things we always ask is about, do they have high blood pressure? What medications are they on? And cardiovascular health. And so I think we can be one of the primary medical providers that gives good advice to our patients to promote better health overall. I think
Now anybody is
what's the
having question,
percentage
other
of the
question?
orange? One more quick question. It said, what's the percentage of the orange tinted lenses? They look pretty dark to me. I would say they're at more than a 50% tint. But again, you can have some blue blocking that maybe doesn't have to be real dark. But they're probably the ones that I've seen that say they block a very good percentage of the blue are probably 50% or more in terms of the tint. So I hope this has helped you, and I hope it's helped you to help your patients. And maybe we all need to do a little bit better in terms of taking care of ourselves and getting off our devices just before sleep.
Thank you so much, ma'am, for your wonderful event and sharing your knowledge with us. And thank you so much, ma'am. And anybody is having any query, let them ask.
Yes, and if any questions come in later, feel free to send them to Adnan. He can put them in the WhatsApp for me, and I'm happy to answer them. And I can even, Adnan, if you want to, if anyone asks, I don't know if it's difficult for you in any way, but if you know who registered and you want to make a PDF of the slides and send that out, I'm okay with that.
Okay, ma'am. Thank you so much, ma'am. Thank you so much, ma'am.
Sure, ma'am. I will connect you if any question else. I can surely form the PDF and will share to you later.
Thanks. So enjoy the
Thank
rest
you,
of
ma'am.
your day. And it's 1:30 in the morning here now, so it's time for me to go to sleep.
Okay,
Yeah,
ma'am.
yeah.
Thank you so
Good
much,
night, ma'am.
ma'am.
Thank you all very much.
Okay, ma'am.
Bye-bye.
Bye-bye, ma'am.